Hi, so I think it's working. So today I'll introduce you with the interface of COMSOL. So when you will open the COMSOL, so you will get this kind of interface. So so if you want to work on COMSOL, then you can go through model wizard or blank model. So if you click blank model, you will get directly with the uh, COMSOL interface. And if you click model wizard, so for you, I can click model wizard. So if you click model wizard, then you will get this kind of interface. So if you want to work on 0D or 1D or 1D asymmetric, then 2D or 2D symmetric or 3D, any kind of model. Um, so for 1D, on the simulation, you can click here for, okay, so let me clear it, what is a asymmetric. Okay, so suppose your model has uh, a dimension of, for example, 100 nanometer. So and the um, uh, so like this on is your model. Okay, so here you can see that if you cut your model from the middle of this shape, then this part and this part are similar. Okay, so this part is the symmetric of this part. So you can simulate this part only for reducing the simulation time. So then you can just select only symmetric. Okay, for the case of 2D symmetric, this part also, this is also the same thing. So you can select 2D, 1D, or 3D. Any which dimension you want to work, then okay, if you select on D, for example, then you have to select physics. Okay, so for example, you want to work on, so there are different kind of physics for ACDC module. So there you can see that inside ACDC module you have electric field or current. So if you want to work on electrical circuit or something like that, then you have to choose HDC module. So you have electrical field and current. Um, Inside electrical field and current, you will get electrostatic, electric current. So electromagnetic heating. Inside electromagnetic heating, you will get Joule heating or Joule heating and thermal expansion. So that is okay, and then electrical circuit. So that's actually provide a CDC module of COMSOL, and then you will get okay. So then you will get acoustics, chemical, um, species, transport. Okay, so different kind of physics you will get actually from here. So also you can simulate mathematics inside COMSOL. So inside mathematics you will get PD interface, OD, okay, optimization, and big interface, okay, distance. So that's all. The, lots of physics here you can choose. Okay, so you have to choose your correct physics. For example, you want to work on let me choose on. So you want to work on a heat transfer in solid. Okay, so then you have to click here and then you can add. Okay, just you can add it. Okay. Okay, it will take some time. So okay, then it added here. Okay, then you can select study. Okay, so if you select study, then you have to choose which study you have to do. Okay, there is different. This physics actually offer stationary study, time dependent study, or thermal perturbation, right? Okay, perturbation study. So on. Okay. Eisen frequency, uh, Eisen values, okay, vintage study. Okay, so if you want to just do time dependent study, so for example, you want to run how temperature actually works. So you have to double click here. So double click time dependent, then it will. Okay, so this is the main interface of COMSOL actually here. Okay, so what we have done, we select 1D geometry, and this is 1D geometry. Okay, then we have to add materials, and we select heat transfer in solids as a physics, and we select time dependent study. Okay, so that's actually here we actually learn from how you can select this everything. Okay, and another thing. Okay, so for a new. Okay, so initially we just go through with a model wizard. Okay, so now if you just select blank model, select blank model. Uh, no, actually no. Okay, if you select blank model, then it will directly give this interface actually. So here you can see that in our past model, what we have seen, we select the physics, geometry, etc. So studies. But here you will get a totally blank model actually. You didn't select anything. So if you just select blank model, then you have to select material. Okay, so um, okay. So you have to select materials, physics, study results. Okay, so I'm sorry. Okay, model builder. So we are working on model builder, no problem. Okay, so from home, you can see that uh, at first you have to select what you have to select. You have to select the geometry, right? So here you can see that add component. Okay, so from add component, you can select 1D, 2D, or 3D. Okay, so I'm selecting 1D, double click. Okay, so you got the geometry actually here. Okay, then uh, all the things are enabled here. Okay, so then you have to add which thing you have to add. Okay, then you have to add physics. Okay, you select geometry, right? So then materials, material is insert here automatically. Don't worry about it. Then you have to select physics. Okay, from physics you can select here, double click at physics. Okay, uh, it will open another windows here, I think. Oh, sorry. Okay, not double click, single click actually. I'm sorry. So from if you click on at physics, then you will get this physics interface, which physics you want to actually run. So different kind of physics, as I mentioned before. Plasma physics, radio frequency, semiconductor, structural mechanics, okay, uh, as well as fluid flow, heat transfer, electrochemistry, okay. Okay. Oh, sorry, electric discharge. If you want to work on battery, maybe electric discharge will help you. Uh, chemical specialist, so on. So okay, so if you want to work on radio frequency, then you will get this kind of interface. Okay, if you want to work plasma physics, then you will get all the things here. Okay, so as I select before, heat transfer, right? So heat transfer is solid. You have to just double click here, or you can mm, click here and then add to component one. Okay, so anything you can double click or click and then add to component one. So here you go, you got the physics actually. Then you can close it. Okay, then what do you have to add? Then you have to add studies. Okay, so from add study, okay, you will get this interface again, time dependent. So click time dependent then add study or double click here. Okay. Okay, then you will get add studies. Okay. Another thing you have to add, that is mesh, but mesh actually or COMSOL actually provide automatic. Don't worry about it. So that's the thing of initial interface of COMSOL actually. So uh, maybe okay, then for the geometry, is the crucial part actually. From geometry, you can select length unit as nanometer, micrometer, centimeter, whatever you want. So you can select micrometer. Okay, just I'm going to simulate a single thing, basic thing actually, in heat transfer solids actually. You can select any physics actually, any physics. So for the beginning, I'm just simulating very basic things. Okay, for example, mm, interval. So for example, I'm taking an interval. So in geometry, I select micrometer as the length actually, so, right, unit. So here you can initiate from 0 and then 1 micrometer. So you can build it. So it's start from 0 and end in 1 micrometer. So you can take it as 10 micrometer. Don't worry about it. So that's the thing. Okay. Then as a material, we can, okay, there is a different way to choose material actually. So the best way is click here, right click of your mouse, then add material from library, browse material, blank material. So initially I'm teaching you how you can just add material from library. So click here, then it will add another this here. So what we are working here, heat transfer in solid. So you have to search a material inside heat transfer, right? So what I'm looking for, heat transfer, right? So what is the heat transfer? Sorry, where is the heat transfer? One second, just no material for heat transfer. It's okay. Building. There is some part here. Okay. Oh, sorry, bioheat. So no, I'm talking bioheat. I don't know what's happening console. Thermal. Okay. So okay, whatever. You can search like AU as a cold. Okay, let me check what cold is. So they provide names. So let me check names gold. Okay. Okay, thanks. Then you can close it. Okay. So gold is selected as material here. So it COMSOL actually provide you the material property. If you just use um, building material, then you'll get the building material property, heat capacity, density, thermal conductivity, etc. So then in physics interface, what we are getting here, so cross section area, other things. So from heat transfer in solid, you can what actually I want to do actually. So that's the thing. Mm, For now, what we can do, we can select maybe select an inflow to I don't know, selecting okay, what the thing okay. It's not applicable. I don't know why it's not applicable. Maybe okay. Inflow is not working here. Okay. So what we can do here? um, Okay, hit source, boundary hit source. We can select a boundary hit source. Okay. So this uh, is our boundary hit source, and this would be the uh, output maybe for now. Okay, hit source. Okay, I think there are things. Okay, let me check it. Okay, let me take the temperature. Okay, okay. So we want to check that. Okay, sorry. We want to check the temperature of this part and as well as just a second. Okay, don't do just you can disable it. Okay, then temperature we can select temperature 393 maybe for this port and then duplicate it. So you can deselect one and then select two, and then you can make it 293. Then yeah, okay. So what we have done here, we actually select the temperature of this port is 391. It's kind of 100 degrees Celsius, and then we select the temperature of 29. Sorry, it's maybe 125, right? And this one is 25. Okay, so what do we want to say? Uh, then you can select mesh actually. So for now, we are selecting physics control mesh, and in our next video, maybe we'll work on user control mesh. So first, okay, build. You can select extremely fine mesh or other things. So from here, we select heat transfer in solid is our physics, right? So we are using physics control mesh. So for now we can select actually normal mesh. Okay, that's the thing. Okay, so then let's study. In study, what we can do, we can run it in nanosecond maybe. I don't know, uh, maybe 0 0 to from it will work on 0 to 10 nanosecond with the 10 nanosecond interval. So you can click here or you can select from here. So step, so you start from 0 nanosecond, then the step size is 1 nanosecond and stop 10 nanosecond replace. So you can run it from compute. So is our initial run in COMSOL actually. You can stay. Okay, it's done. Yeah. Conversion plot. So it's done actually. Okay, this is the temperature graph actually. Okay, okay. Let me check. So this is our what this is our gold actually. And this is the temperature. Okay, so uh, you can check from here. Okay, time structure. Okay, for now, what we can do, we simulate the uh, temperature. Okay, so okay, so let me clear it. What we have what we did here. So we simulate this model actually from uh, 0 nanosecond to 10 nanosecond, right? So this was our highest temperature, 125 degrees Celsius, and this one was 120, sorry, 25 degrees Celsius, right? So it's a basic concept that heat will flow from this port to this port, right? So initially this port has high temperature, and as you can see that this one for 0 nanosecond and temperature. Okay, so the temperature flow is like okay. So let me check it for you how it's working actually. Okay, it's a line graph. So it is start from 0 nanometer, so that is port 1, and end in uh, 10 nanometer, right? That is port 2. So here you can see okay, for 0 nanosecond the temperature is so high, then it's decrease with uh, the with the length of the gold. And then if you see for at 10 nanosecond the temperature is flow through this part actually. Okay, we will clear it. If we just if we can just plot the port graph actually. Okay, so 1D plot group from results, you can select only plot group, then you can plot point graph, then it will be easy to understand actually. So point graph, so this is the point one. So if you plot, temperature is kind of temperature is constant, right, all the time, because we are working on, sorry, so all the time the temperature is constant for port one, right? Okay, and then if we say the temperature of port two, the temperature of port 2 is also constant, right? Because in the uh, from here you can see in this time no heat actually flow from port 1 to port 2. So actually it's decay in actually heat follow from this part to this part. Okay, that's the thing. So what we can do, we can just select, we can just uh, take the interface, sorry, interval uh, 10 nanosecond, and we can run it for 100 nanoseconds maybe. Okay, let me check. Okay, okay, now maybe it's working, right? Okay, okay, but temperature is not changing. Okay, yeah, but we can check the heat actually. Okay, so if you want to change the expression from here, it's the T, right, temperature. But if you want to change the expression, you can change from okay, from here. Okay, so then component one, we are running heat transfer in solid, then temperature, the temperature, and if we want to see the heat, okay, heat source, no, heat and work source, energy burn. What we want to see, how to normal vector. Okay, total results. Okay, okay. Okay, total heat flux maybe for proton, total heat flux is very high. The initial time, then it decay for put to. Okay, there you go. That is the thing. So maybe we run it for more time. Actually, okay, not nanosecond. We can take it as microsecond. Then we'll get a better result maybe. Okay, it's done. What happened? And which didn't change it. Okay, let me check it. We're running from 0 to 100 microsecond. Okay. So if we check the temperature, okay, temperature, then let's see, temperature is again the same. Okay, for now, okay, from list, okay, for 10 microsecond. Ah, I got it. So actually, what it has, so it actually, so at the initial for 0 microsecond, at the initial case, the temperature, the heat distribution was like this. The top of the cold was temperature was actually 393 Kelvin, and here you can see 0.5926 micrometer. The temperature is 291, and throughout the media, the temperature is 291. So if we change it 10 microsecond, then the temperature of uh, the port is 391, and the temperature distribute throughout the gold, and at the end of the because we actually make constant of the temperature of port 2, right? So here we selected constant actually. That's why uh, it didn't actually change the temperature here. If we just change it, if we just disable it, then we can check it actually. Then it will work, I think. Okay, let's simulate it. Okay. Now you can check it out. Okay, what actually going on here? So you can check that at 0 mic. I'm sorry.